Good afternoon, everyone. So my name is Haiquan from Sinoma. It's my pleasure to have this presentation to everyone here. So actually, I believe I'm the only one from the other side of this planet. So in my time is 4 in the morning. So I hope you can encourage me. Otherwise, I may fall asleep during my presentation. Okay, the topic of my presentation is development of key technology and equipment for calcined clay of Sinoma. There are total three parts. First one will research background of clay flash calcination technology. The second one is Sinoma's clay flash calcination technology, and the last one will be the engineering application of clay flash calcination. Let's go to the first part. Research background of clay flash calcination technology. You can see today, greenhouse effect become more and more critical, and CO2 is the most important greenhouse gases. And cement industry discharge huge amount of CO2. And how to decrease CO2 emission is a challenge of cement industry. And I think LC3 is a good substitution of clinker. So this is the leading research institute of LC3. Actually, LC3 was proposed eventually by Professor Karen, and also they lead the team from Switzerland and also India and Cuba to do the R&D. Sinoma joined this team in year 2015. So Sinoma and then become an important member for these technologies. Sinoma focus on flash calcination, production, and application of these technologies. So the benefit of LC3 is a lot of people mentioned in this conference. You can see actually LC3 is a family of cements. So you can see from here, okay? Maybe here is better, okay? So there are different type of cement, Portland cement, PPC 30, LC3 50, and LC3 65. The number after LC3 is clinker ratio. You can see here, the clinker ratio from LC3 is much lower than Portland cement. But of course, there will be no compromise with this kind of calcined clay in the clinker. You can see the strength from 1 day, 7 days, 28 days, or 90 days. They're all almost the same strength. And the benefit is 45% less clinker and less CO2, and also better chlorine resistance. So this is the benefit of LC3. And you see the vision of calcined clay. Calcined clay is a very important part of LC3. That's why we came to the LC3. We can see the big players in the cement industry, like LafargeHolcim or Heidelberg Cement, in their vision for the future for CO2 neutralities. So they also, all of them, you can see here, sorry. So what happened? Here and here, they also mentioned, the calcined clay to be used in their cement. And now we have the question, how to produce calcined clay? So I think a lot of people want to produce calcined clay is from cement industry. In the parallel system of clinker production, there are two fires. One is in the precalciner, the other is in the kiln. But compared with clinker calcination, clay is much easier. They only need one fire to produce calcined clay. So then there will be a choice. You go with a precalciner or go to the kiln. So this is basically two technology. One is for flash calcination, the other is the rotary kiln calcination. The R&D team did a lot of R&D work for the quality of the calcined clay. So if we go to very micro, view of the particles, we found the particle shape of the calcined clay from flash calcination is much better than the clay from rotary kiln calcined. Okay, that's the reason why the calcined clay from flash calcination have a higher pozzolanic activities and better workabilities. Moreover, for the flash calcination, have lower fuel consumption and easily controlled calcination temperature. So this is the main benefit of flash calcination. And now we want to show you how about the Sinoma's clay flash calcination technologies. So since we think flash calcination process have the benefit of good gas-solid contact effect, suitable for mass production and high thermal efficiency and stable product quality, we want to go flash calcination process. So this is our main target of R&D. This is the typical process of flash calcination. I think you can see we have raw material feeding and preheating and calcination, cooling, waste gas treatment, and product maintenance. So compared with clinker production, it's much easier. So it's very easy to produce. But you see, I mentioned here, the moisture should be less than 5% for the feeding of the materials. If the material's moisture is more than 5%, we have to do something for raw material handling, for drying the raw material. Maybe we use a vertical roller mill, maybe we use rotary dryers. I have to mention, you know, if the moisture is extremely high, maybe this clay is not suitable for clay calcination because, you know, we have to use a lot of energy to dry the clay. It recalled me one project last year. We talked with one of our clients for a project in the US. They want to dig the clay from the pond, so the moisture is extremely high. So after all kinds of calculations, you know, both the CAPEX and OPEX of drying the clay is more than the clay calcination. So be careful. If your clay is the moisture is very high, we must do some calculation to see is it economical or not. So here is a characteristic of, you know, our system. The preheating system consists of 5-stage preheater and an inline calciner. The temperature in the calciner can be controlled in the range of 700 to 950. You may see this range is 250 is a very big range. But you know, we must be careful because the clay have different properties. Different clay, you know, we all know under calcination and over calcination is not good for the quality, for the stable quality of the product. So we will do the test to see which temperature is suitable for this kind of clay for the calcination. And then we will narrow the range in our design of the precalciner and preheater and the calciner to find a good temperature. That will control the quality of the calcined clay of the product. And the next one, by control the retention time of the materials in the calciner, the calcination reaction is ensured to be complete. The calcination reaction takes only a few seconds due to the high efficiency calciner design. And the suspension cooling system consists of 3 cyclones to cool down the clay to above 100 degrees. So this is a characteristic. And then we come to the part of the color control. No matter from, you know, from R&D and for the application of. Okay, so let's go to the point. For the color control, you know, they will come from 2 parts. One is for calcination, one is from the cooling. So we will create a reducing atmosphere in the calciner, and then use 2-stage suspension cooling system to cool down the calcined clay. You can see from the left part, we can see the 1st-stage cooling process. You know, if we control the atmosphere properly, and then we can have the gray color. If not, it's reddish. And then we go to the 2nd stage. So the tricky part is the temperature control. So up to what temperature we cool down the calcined clay for the 1st stage. So we have to do the test. Okay? If we're going too fast, that means the temperature is still high. And in the 2nd stage, the calcined clay become reddish again. If we're going too late, that means we cool down in the 1st stage, we cool down too low, and then it's a waste of energy. So we must do the test to find the suitable temperature to do the two-stage cooling. So this is our laboratory facilities in our companies. We have thermal simulation platform, and also suspension calcination test platform, and also all the machineries to the test of the materials. So whenever the client wants to have some materials, we will do the test first to find a suitable configuration of the machineries and the design of the machineries. We also do the computerized simulation work. So from the right side, you can see this 3D model of our equipment for the clay calcination. They have 4 special features. First one is the special cooling configuration to get. Okay, I cannot see that. Perfect cooling effect and the fuel consumption, and the special arrangement of the preheater. For preheater and precalciner, in this flash calcination, we have 5 stages for preheating and calcination, and another 3 stages for cooling. So the tower could be very high. So we have special arrangement to lower the overall height of the building. That means decrease the total investment, of course. And also we have a special burner configuration, and the last is special color control. The last one will be the engineering application of clay flash calcination. So from the left side, you can see the plant. The trial calcination is in 2019. And also from the right side, you can see the equipment. So this pilot production was in January 2019. Okay, is in China, in Jiangsu province. The capacity is 600 tons per day calcined clay, and the fuel consumption is something around 420 to 450 kilocalories per kilo calcined clay. This is the first one. And the second engineering application is last year, November. Okay, it's in Henan province, also in China. The capacity is much bigger. It's 1,350 tons per day. And also, the heat consumption become less, around 400 only. Another thing is about, the pressure drop is only 5,450 with altogether 8 cyclones. And product temperature is only 79. Here is the raw materials for that plant. You can from the right side, you can see all the tests we did. You can see here, this is the calcination point. So this is a temperature range. So by the test, we found a suitable range for the calcination, and then we design the system accordingly to make sure the calcination is complete and not over calcination. And also, the aluminum, so the quality, and then the quality of the product, calcined clay. So here, the superior product, you see, it is aluminum, dissolved aluminum. So it's the index for the qualities. The good quality is around 30%, but from our system, we have 35%. We have nearby competitors. They use rotary kiln, so their figure is around 30%, something like that. But our product quality is 35. That means it's better, and then have a better market position like that. Okay, so thank you for your attention. I'm lucky I'm not for sleep.